Hey, welcome back. Again, if you have any questions, let's deal with them right now, okay? It's a good point in time here when we kind of pause for a moment. And we do get a call coming in from Steve at Pete Harkness. Steve, go ahead. Okay, hey, let's try Mark. Mark's still not working. May want to try to call back in again. Something's going on there at your location, okay? And we got another call trying to work its way through, so we'll pause here a minute before we get started here and start talking more about Module 2 and about some components here, and got a couple demos for you, and show you some more neat features here of the Quadrasteer system.
And of course, this one's going to be slow getting here, or maybe not at all, huh?
All right, Mark, go ahead. Hey, dude, you got to call the help desk, man. Something's wrong with your stuff there and just not working out, so don't bother. All right. Hey, what's next? We got another question. Let's take a look at it.
There it is. What components were added to this axle to make it steerable? Think about that. Give us a call. All right, let's go ahead and talk to Brian here. Brian, any thoughts?
We have ball joints, tie rods, CV joints, and quarter shafts.
All right, named off a few of them for us there. Good deal, Brian. Hey, appreciate that. Who else we got?
Terry.
I got Terry. Terry, go ahead. Harry, are you there? All right, not hearing anything from Harry's mic there. So yeah, we've added a good number of components to this thing to make it steerable. See a couple more calls working their way through. We've already named off the ball joints, obviously added in there. Okay, that was a big part of it. Okay, got to have that flexibility to make it steerable here, and hopefully get a couple more calls to pop in there. And it looks like Steve.
You got the spindles too, and the rack itself.
Yeah, the whole rack assembly itself, the motor and the gears and all that stuff. We've also got the tie rods, inner and outer tie rods been added in here. All right, Steve, appreciate that. And who else we got?
Steven.
Another Steven.
Yes, you have also the limited slip differential.
All right. Okay, got that Dana 9 3/4 inch axle here. Fairly heavy duty. Good deal. Appreciate that.
Matthew.
And Matthew, go ahead.
Bearing?
There we go. That's the other one I was looking for, is that wheel bearing. Okay, that's been added in. Obviously, before we had the wheel bearing inside the housing. Don't have that anymore. Got a bearing, sealed bearing on the outside, just like we do on a normal front wheel steer. All right, so good number of components here have been added into this thing. I guess you could also include the module, the wiring harness. We also have a real heavy wiring harness that runs from the front to the back of the vehicle here to supply power to this unit. Okay, and we'll be looking at some of that wiring a little bit later as we go into other parts of the system. All right, now let's get into a little bit more information on the rear wheel steering control module. That's going to be on page 212 in your participant guide. Now, the rear wheel steering control module, obviously the brains of the situation here, right? It's controlling what's going on, controls the actuator. That module is mounted in the rear underbody. It's near the spare tire on a bracket connected to the frame. You can see it there. You can see the wiring harness going to that. You can see the ground strap hanging there, okay? Definitely very important to have that ground strap connected properly. Now we're going to use that to determine the correct amount of rear wheel steering needed at the rear wheels. It's going to do that based on the inputs that it receives. It's going to energize the steering motor, turn the rear wheels either left or right. And we've got a long list of inputs and outputs on that. If you take a look at page 213 in your participant guide, you can see that list labeled out right there. Some of the unique features are listed in the participant guide again on page 213. First off, anytime that controller is replaced, that truck's going to require an alignment. Okay, we've got to do the learn alignment portion and the actual angle measurement. We may not have to make a change to the angles. They may be correct, but we have to put it up in the rack and check it. And then we got to give it some information here so it knows exactly where the front and rear position sensors need to be centered up. Now for 2002, calibrations are unique to each vehicle. We got 3 different part numbers. You can see the part number there on the top of the module. You can also get that module number right through the Tech 2. So, hey, if that label gets a little bit too wet and it washes away or something, not a big deal. You can use the Tech 2 to pull that up. So again, we talk about O2. 3 different part numbers. Each has its own software calibration, set up a little bit differently. Now, when we jump into O3 and newer, there's only 1 part number. Okay, only 1 part number. You got to program it through TIS. It's not going to work correctly until you do that. There's also a couple of DTCs we want to hit on here for that rear control module, and that is a C0550. Andrew mentioned that earlier as we're looking at the codes that could occur there. And the other one is a U1305. That's a communications code. Okay? So again, C0550 is internal module failure, but there are other outside influences that could affect that, so please take a look for any bulletins and PIs before we go replacing a module. And the U1305, remember, we are communicating on Class 2 bus. If other modules don't hear from this particular rear steer module, U1305 is the DTC that will set in those other modules, signaling, hey, we got a problem with rear steer, not communicating. All right, before we continue on, do have another question for you here. Let's go ahead and take a look. This is number 5 on your keypads. Which of the following is a true statement about the 2002 control module? Is it A, there's only 1 software calibration? B, a DTC C0550 can be set only 1 way? C, has 3 part numbers with 3 software calibrations? Or D, there are 3 part numbers for the module with 1 calibration? All right, taking a look there, you can see C is the answer we're looking for. 3 part numbers, 3 software calibrations. Again, we've got those part numbers listed right on the module, and you can also pick those up using the Tech 2. All right, well, next up, we're going to talk a little bit about the actuator here, see what's going on. Oh, we got a call. Let's go ahead and grab that first.
We have Steve from Tri-Buick again.
I may have been not paying attention, but is there a sensor in the rear steering actuator there to tell what position the wheels are at, or is it by the yaw?
Oh, you're paying close attention. No problem at all. We haven't gotten to it. We're definitely going to be talking about it. It is coming up, and there is a sensor letting the system know. It's kind of a feedback. Did it actually do what it was supposed to do? Did we turn the rear wheels this number of degrees that the module commanded? It's just all the way down at the bottom of our actuator. We definitely will hit on it, Steve. Pretty perceptive, though, huh?
Yeah, absolutely. Hey, let's do this. Let's take a look on page 2-14. We're going to talk a little. We're going to start talking more about the rear actuator and more about the internal components. But what we want to take a look at next is a short video that's going to kind of demonstrate normal associated noises with the system. Because I think Mike mentioned it earlier. Beneath this motor, we have 2 planetary gear sets that give us a 45-to-1 gear ratio. Well, hey, with some gear sets in there, you may have to expect a certain amount of noise, okay? Let's take a look at the video, and it's going to demonstrate what's acceptable.
During normal vehicle operation, no operating noise from the rear wheel steering actuator should be audible. However, when being commanded by the Tech 2, sound can be heard from the actuator during operation, which is normal.
All right, so that basically just says that, you know, if you're sitting in one place, you have the Tech 2 hooked up, you're getting those wheels to go to their max 12 degrees in either direction, hey, you may hear some noise, okay? But once you get moving, you know, you're rolling down the road, you got some wind noise and some road noise coming in the mix there, you shouldn't be hearing anything, neither should your customer, okay? Now, another DTC that we want to talk about is C0543. If you ever encounter a C0543, that's telling you that the command is being issued to turn the actuator, or to turn the wheels, I guess I should say, but it just physically can't do it. Something is binding, something is bound with this assembly, and it's preventing the wheels from turning, and it's kind of like an overload situation. The system shuts down and flags that C0543. Okay.
All right, next up we want to take a look at the tie rod assembly, see how all that is assembled on this vehicle. Obviously, if we're getting some movement back here that we don't expect, that's where we're going to have to look first, right? So we got to do a good thorough inspection on these, and we need to know how to reassemble these parts. So let's go ahead and take a look over here on this far end of the axle. We've got things disassembled. We're going to go ahead and start putting things back together at this point. Now, what we've got here, a whole bunch of parts and pieces and special tools that we're going to be using as well. They're all called out on page 215 in your participant guide. Now, the first thing we want to do here is we want to reinstall our support nut. Okay, that's what they call that. You can see the two holes in there. That's going to be for a spanner wrench that we're going to use, a special tool to torque that thing down. Now, this is a left-hand thread. Got threads on the inner portion and on the outer portion. So we want to thread this back onto the actuator assembly here, get that lined up, spin that into place. And we do need to grab our special tools, J44665. And you can see the two prongs on there. Hopefully that's what we're going to use to set things up here. Okay? Once we get that into the holes, then we can put our wrench in, our ratchet in there and tighten it down to specifications. So just slip that into the two holes here and torque it down. Once that's set, we'll set that tool down for the moment. Now, we can grab our inner tie rod. There's the inner tie rod assembly there, and this is just a right-hand thread. It's going to go in the center here. Okay? Thread that on the normal fashion, and once we get that into place, we're going to need another special tool to help us out. Hey, take a look at that real quick. Right there. Okay? Got two sides to it, large and a small side. We're going to be using the smaller side for the moment. That's J44665-2. Okay, slides right onto the flats there on that assembly, and once again, we can torque that down to the proper specs. Now, once we've got that all in place, the next item that we got to put on in there is what we call a support clamp. Okay, that is our support clamp. Basically, it's a safety device. That slides over the axle, or over the tie rod, excuse me, and threads on to this piece here. Now, what have we done? We've captured that joint. Okay, we've captured that joint in between so that it can't go anywhere. Okay, again, thread it onto the support nut. Now we need both those special tools back at this point. Okay, J44665-1, slide that into the holes back there, and J44665-2. Now we're going to use the larger side there, and we're going to work against the two of them, torque things down to our specification. Okay, ratchet into each one and torque that down. All right, once all that's in place, definitely important to remember, we need to install a boot. Now, there is your boot assembly right there. Obviously, we got to do a good inspection on that before we slide it into place. Okay, we're looking for any rips or tears, anything like that. So let's go ahead and slide that back on. Once we get that into place, now we would put our clamps on either end. Now, we're not going to do that today because we keep taking this thing apart, so it wouldn't make any sense to do that. But you definitely want to. We want a watertight assembly here. Okay? This is on the axle assembly, sits fairly low. Hey, if we're launching a boat or something, this is going in the water. This assembly can't deal with water, so we got to keep it sealed. We want to make sure we're in good shape there. All right, so we got the boot on. We're in good shape at that point. Next off, we do have a jam nut out on the outer edge here. Okay, got a jam nut that's got to get threaded on. Once we get that into place, then we head to our outer tie rod. Now, got that on there a little ways. Here's our outer tie rod. Now, I want to point out, right down at the base there, we got a little nub on this thing. Okay, and that nub right there is another safety device. And we'll show you a little bit more about that in a minute. There's a bracket that fits over that, kind of locks all of that into place. Okay, so we'll go ahead and get that threaded on real quick. Once we do that, obviously, we've got to head over to the alignment rack. We need to set our toe. The only adjustment we can make on this rear axle is toe. No caster, no camber. But that is our complete assembly there. Okay? Once we've got that done, like I say, we want to take a look at the bracket that we're dealing with, and Andrew's got that on the other side there. You can see our bracket assembly here, and you can see the nub on that tie rod, and that fits into the hole in the bracket assembly. Andrew, you want to go ahead and show us what we're dealing with there?
Yeah, here we are. Here's that bracket, and there's two bolts that hold it in place here. We'll get the second one out. We already got it prepped here. All right, and again, here's that nub, okay, that redundant nub.
And again, it's a safety device. Just
Yeah,
holds things together
exactly.
if that ball joint starts to come loose.
Yeah. Now, if we got to remove our tie rod, what do we got to do here? Hey, we got to remove the jam nut, obviously. Okay, we get that jam nut, but it's not recommended that we get a big hammer and start smacking this thing on the end to try to disengage it. And that's because we got a fairly decent sized arm right here, okay? Yeah, we got a lot of leverage there, okay? We start banging on the end of this thing, we could put a hairline fracture somewhere in this arm, and of course, then we're going to have problems, okay, to say the least. So to do it, to remove it, you get that jam nut out of the way, then you want to use your tie rod remover, okay? This is the J24319B. This thing's been around for quite some time, okay, 24319B. It's almost like a little press, okay? All you got to do here is fit it around the arm, like that. You want to come down with the nut. Okay, and obviously you'd have the nut out of position when you're doing this. And you just start reefing down on it here, and you're going to pop that tie rod right out of place. You're going to pop it right out of place, and you're going to be good to go.
All right. Well, the next thing we want to talk about is our return to center spring. Fairly major part of this system. Very powerful spring. We shut the system down. We're actually going to use this spring to push the rear wheels back to the centered position. That's a lot of force. You can see where it sits there in the diagram. Okay? And we actually have one pulled out here for you today as well. So there is that spring. You can see the flat coils in that. You can't budge it. You can't do anything with this by hand. Okay? A lot of force required. It does sit inside the actuator housing in here, and it is not serviceable. Okay? You can't do anything with this. Again, great picture there showing those flat coils. So, why are we showing it to you? Well, it's important to understand how this thing works. Okay? How do we get the rear wheels back to the center position? This coil spring is going to do it. Now, the reason it's not serviceable is because it's under a lot of pressure in there. You know what? You take it out, it's going to spring out at you. Got to be really, really careful. I know I didn't want to do it. Andrew said, hell no. So, who'd that leave? That left it to Kevin. We let him do it. So he got it out of there for us, didn't get hurt. Now we can show it to you. But otherwise, obviously not a good idea. We don't want to go there at all. All right. Next up, we got a question for you. This is number 6 on your keypads. What should you suspect if you notice a slight whining noise from the actuator while we're operating the system? A, the actuator should be replaced. B, the inner tie rod is worn. C, the actuator is working normally. Or D, the rear position sensor is out of alignment. All right, let's take a look here. Yeah, C is the correct answer there. Good deal. Looks like everybody's on track. That actuator is working normally. Definitely expect some noise from it. 45-to-1 gear ratio in there. It's got to make some kind of noise.
Or else it's not working.
Yeah, yeah, it's not doing anything, right?
All right, hey, take a look on page 2-17. We have another tech tip listed for you, and it has to do with the inner tie rod boot that we saw Mike assemble there for us. And it's about a recommended service procedure. Now, if you go into the part system, you can get the part number for that inner tie rod boot by itself, okay? But the only time we should be doing that is if you damaged it yourself. Maybe you bumped it with the hoist arm, or while you're doing the tie rod, while you're replacing the inner tie rod, maybe you tweaked it a little bit too much and you ripped it or whatnot, okay? If that's the case, it's acceptable for you to go and obtain a new one from parts. However, if you ever get a vehicle in where you got some fault codes and you're doing your diagnosis and you come to the conclusion that you have water contamination inside the actuator and you find out that it's from a ripped boot, you can't just replace the boot, okay, like we see in the photo. You can't just replace the boot. And it's for this simple reason. You can't determine how much water, or for that fact, how much moisture is inside the whole actuator, and you may just replace that boot and then you seal it up tight, but you still have a large moisture content in the actuator housing, and you can see some repeat failures of some of these components. So the recommended service procedure, if you do encounter a leak due to the boot like that, is to replace the whole actuator, and just that will come with new boots on that new component.
All right, well, next up, we got another question for you. This is a call-in question, and it asks, what steering components could cause this vehicle to drift? Think about that. Give us a call.
Mike, we have Steve calling in.
All right, Steve, go ahead.
The tie rods, if they get loose, cause the wheels to shake, kind of drift,
Yeah.
or the actuator inside the steering rack.
Yeah, I'm not sure on the actuator. I definitely agree with the tie rods. Actually, I can't say that I've run into it, but gut feeling would be if we get a little bit of movement going on in there, the system's going to see it. It's going to shut down. Okay, so it'll be very brief. It's going to shut the system down, use that return to center spring to kind of hold things steady for us. So I wouldn't expect that that'd give us too much of a problem. But definitely the tie rods, a major fault point we need to look at there. All right, any other calls coming in?
Cody.
How about Cody? Cody, go ahead.
Tire pressure, worn parts, and alignment.
There we go. Yeah, let's think simple here, okay? How about tire pressure? So simple, but it happens a lot. Can cause that same kind of problem. And just because we got rear steer doesn't mean we have to get back here and find a problem in the back. Could still be up front. Okay, you could have something worn and loose up in the front of the vehicle as well. So got to think about it. Obviously, road test it. See if you can feel out where does it come from. Does it come from the front or the back, and then do a good visual inspection, check things out. All right, good deal, guys. Hey, great thoughts there. Now, next thing we want to do here is talk about some more special tools. How do we disassemble our ball joints?
Yeah, we have a couple more special tools. These are essential tools, just like the ones you showed us for the tie rod demo. Essential tools for Chevrolet and GMC. And basically, it's all about how to remove this upper ball joint. If we take a look here, to remove that upper ball joint, we're going to have to remove these top 4 nuts, okay, that hold it in position. And there's also this nut down here on the bottom. So first you want to remove these 4 up top. Okay, no special tools required there. What about this thing? It's kind of tight to get a socket on in there, and you may not be able to get too much leverage with a wrench. So they've developed a special tool for us. This is the J44 644. Look at that. J44 644. And you get an idea. You fit your half-inch drive, your ratchet there, or your breaker bar right on that end, and then the other end goes right on there. Goes right on there, and then you just break it loose. Okay, so you got the nut broken loose, you remove the nut, get your special tool out, and now you got to press this out of here. Okay, that's our load-bearing ball joint, so it is pressed in there, and now we got to use the J44 663. And there are the numbers down there, J44 663. All right, and this is just like a miniature press. So all you want to do with this job, you put it on there, you put it on, and what you're going to do is that bolt's going to contact the bottom of the stud, bottom of the ball joint stud. And you get it in place there, and now you just tighten this up with a box wrench. And what's going to happen is you're forcing it upwards, right? So you're going to push that stud, or the ball joint, right out of where it's at. And then you're just, you're good to go. You get it out of there and you can smack your new one in, okay? Torque it down, you're good to go.
It doesn't take much either, does it? You just got to move it a slight amount. It's just a small bit of press-in area there. As soon as you loosen it up a little bit, it comes right out for you.
Yeah, it's not that complicated.
All right, now if you got any questions, please do feel free to go ahead and press that call button, get those calls headed in this way, try and get those answered for you. Next thing, though, we're going to talk about here is taking a look at this rack assembly. What's going on with that thing?
How about that rear position sensor?
Yeah,
You know,
it's all part of that.
let's talk about the rear position sensor. Okay, where you're going to find the rear position sensor, it's going to be at the lowest most portion of the actuator. You got to remove this skid plate. So you get that skid plate out of there, and now you're getting an idea where we're talking about. You see the wiring going to it, all right? So you see the wiring right there, but there's also another pressed-in cover. This thing you're looking at on the bottom, that is a pressed-in cover on the bottom side. Now, you have to you have to remove that cover. Okay, just pressed in. You can just get like a screwdriver or something like that and pry it out. Disconnect the wiring, and you should be good to go. Now, once you get the bottom of that pressed in cover out, this is what you'd see. This is the bottom of the rear position sensor. All right, and you see right here we got 4 metal pads. That's where the fasteners hold it in place. Now that you know where this is at, all right, let's face it, like we've been talking about at the boat ramp, this thing is going to be submerged. No ifs, ands, or buts about it. It is going to be underwater. You want to make sure that you have a good tight seal with this unit. All right? Well, that requires us to get the torque wrench out. What is it, Mike? 35 pound-inches?
That's it.
Pound-inches, okay? 35 pound-inches, use blue thread locker, the removable kind, because you don't want these fasteners backing out. Mike, if we could turn that over, let's take a look at the bottom side. There you have it. That's what you'd see when you remove it. Now, anytime you R&R this, you always want to install a new O-ring. Whether you're putting the old one back in or putting a new one on, always use a new O-ring. And you want to do that because you want to make a good seal. You don't want any contamination coming in. All right? Now, if you ever remove this for any kind of diagnostic purposes, and you notice on the inner side of that ring that there's some oil and or water, either case, you got a source of a leak somewhere in that actuator, and chances are it's probably going to prompt you to have to replace the entire actuator. Well, hey, now that you know where it's at and what it looks like, maybe we should talk about its purpose. Okay? The purpose of this is like you said, we had a caller call in and start asking questions. It's a feedback to the control module. The control module tells the motor, okay, to turn the actuator to get the wheels turned in a certain direction, and it needs to have this sensor to back that up, so to speak,
Yeah.
and to make sure that the action took place, okay? Because you get an idea where it's at. It's directly below the motor on here, okay? So it's going to see, if everything's working right, it should be seeing all movement of that motor, and it should be able to tell the control module that, hey, I saw motor direction or motor movement in this direction, this many degrees.
All right, well, how's it do that? Well, let's go ahead and talk about that a little bit. Let's see how the sensor actually operates. And start things off with, we're going to take a look at a video. This video is going to show you the movement of the actuator as it compares to the sensor. Let's take a look.
Once the mode select switch is placed in one of the rear wheel steer mode selections, the rear wheel steering control module sends a signal to the motor assembly. The rear wheel steering motor then activates the planetary gear sets inside the motor housing. The planetary gear sets turn the pinion gear. The pinion gear drives the steering rack along its teeth and the rear position steering sensor through its center. As the rack steers the rear wheels in the commanded direction, the rear position sensor sends a corresponding signal back to the control module indicating the position of the rear wheels. This sequence continues on a constant basis while the mode select switch is in one of the 4 wheel steer positions.
Okay, let's talk about how the sensor operates electrically. Okay, we have a couple of diagrams to help illustrate that. If we take a look at our first one, it's with the control module and the sensor. Here you see the sensor, here you see the control module. Hey, just like other circuits or other sensors in the system here, this one works on a 5-volt reference, has your sensor ground, your low ref, and then we have, look at that, we have 2 signals. We have position 1 signal and position 2 signal. So there's really like 2 sensors in one component.
Yeah. And we're going to talk about those in just a minute to show you exactly how we get those particular signals and how they work together. Before we do that, though, got another question for you. This is question number 7 on your keypads. Does that rear position sensor obtain its data from circuits internal to the steering motor? What do you think? Yes or no? All right, taking a look at those results there. Tell you what, no is the answer we're looking for here. Okay, does not get us information from circuits internal to the motor. Now, I've got an extra motor assembly sitting here, and there is our motor assembly. You can see the wiring coming off of that. Well, we're in the same harness, but here's that connector. Okay, now that connector is going to go to our sensor. this is where the information's coming from, okay? That plugs on there. That's where we're going to pick that information up from. So that is completely separate, okay? Goes into the harness here and follows through, heads up to our module. But it is separate circuits, okay? So it's not involved together. It's not getting information from the motor. And before that falls on the floor, I think I'm going to go grab onto that. All right. So again, give you a little bit of information how this particular setup is working. All right. Well, let's continue on here. Let's talk a little bit more about what's going on with this sensor, how we're getting the information off of that sensor. And we've got another diagram here. It gets into a little more information about the two different signals. And you can see that right there. Now, two signals we're dealing with, position A, or position 1 and position 2. Once again, we are dealing with a 5-volt ref. So this just keeps coming up over and over again in this course. What's our center position? 2.5 volts. Okay? So we've got position 1 here. And what we're going to do with that is at the 0 position, 2.5 volts. Turn it one direction, the voltage decreases. Turn it the other direction, voltage increases. We're never going to get to 0. We're never going to get to 5 volts, again, so that we have some range in there to set DTCs. Well, that gives us some kind of an idea of where the rear wheels are, how much we've rotated. But it's not good enough. It's not accurate enough. So they added in this position 2 signal. And you can see there that this ramps up and down multiple times through the range. Well, that way, every time we move the rear wheels, we're going to see some change in voltage. Okay? Now, on position 1, we may see little or no change in the voltage at all. But on position 2, we're going to see a decent amount of change. So we're going to take those two pieces of information together to make our decision exactly how much the rear wheels did turn. Right? How much did that actuator move? Did it operate the way we requested? And again, we get both of them at 2.5 volts. That tells us we are centered. Both sensors, 2.5 volts, tells us we are now centered up on the rear wheels. And that's one of the pieces of information we need for alignment. Okay? As we're trying to align this vehicle, do the electrical alignment and so on, that's exactly what we're trying to set into the module's memory. All right, next up, got another question for you. Question number 8. Which of the following is important to check when replacing the rear position sensor? Is it A, O-ring lubrication, B, bolt torque, C, pinion alignment, or D, sensor cover index marks? All right, there's our correct answer, B, bolt torque. That's what's important here. Got to make sure we get nice, even bolt torque there, using that blue thread locker, getting it down to specifications. Am I boring you here or what?
No. You weren't supposed to see that. Okay, hey, let's keep moving along here. Let's turn to page 2-22. We're going to talk about what's inside the actuator, what's below the motor specifically. Okay? Now what we did is when we were having Kevin take this all apart, we had him take our little gear set assembly out too. Now, here again, we've only done this for demonstration purposes. It's not recommended that you try to disassemble it this far. And here's kind of where it sits. Here's that little cup, okay? And you see our worm gear down here that makes contact with the rack. You also see on the end of the shaft here, if I can find my rear position sensor, that's where it goes. That's how we see what the rack's doing, or what the motor and the whole actuator, I guess, is doing. Okay, that's where it goes into place. Okay. Now, you got a few bolts up here to remove the motor. You take those bolts out, this is what you're going to see. You're going to see our first gear set. See the recess in there? That's where the O-ring goes. Here again, anytime you remove the motor for any reason, put a new O-ring in, because you don't want to contaminate anything in here. Now actually, inside this little cup assembly here, you see there's a seal on the very bottom. We have a special synthetic lubricant. Now, this special synthetic lubricant is there for noise suppression. All right? It's there for noise suppression. Here's our first gear set, 2 gear sets together give us a 45-to-1 gear ratio, so quite a bit of force there. Enough force to turn these wheels on a stationary vehicle, a loaded vehicle, that is. All right? Now this lubricant that's in here, let's take a look at that seal, there it is. The lubricant that's in here, it is non-serviceable. It's also not available from service. So if you accidentally spill this fluid or you contaminate it with some dirt or some debris or whatnot, you got problems, all right, because you can't get it from service. And it's not recommended you just pour some Mobil 1 in there, all right? So do a couple things for me. Make sure when you're removing this motor, you don't got a bunch of rocks, a bunch of debris and everything up here that's going to fall down inwards. And in addition to that, if you are going to remove the motor, it's very important that you make sure that it's still bolted to the assembly. It's still bolted to the axle. Because when it's in this position like this, you take the motor off, you're not going to lose any. But if you got the whole actuator off the axle itself, off the housing, it's laying on the bench and it's flat, if you remove the motor at that point, you can guess what's going to happen. Okay? So again here's our second gear set. Okay? First one's nylon, second one's steel. Now, when you're putting this all back together, here, we'll take a look at that there. When you're putting this all back together, it may require you to do a little finessing with the motor here to get everything to line back up. All right? So it may require you to take the motor and just kind of rotate it there to get the pinion gear for the motor, which is actually the sun gear for our first planetary, to get it to engage. All right? So that's the guts here. That's what's in there. Now, a couple other things we need to tell you here. You see we got a ground right here. All right, this one's obviously loose. But you know something? We got to make sure that that is clean and it is tight. We don't want any high resistance concerns for the motor ground. In addition to that, here we got another ground up by the control module on the end of the harness for the motor. Again, make sure that that's tight, it's clean, no high resistance concerns. Also, as we look here, we got a clip. Here's one clip. Okay, it's a steel clip, steel retaining clip. It's to hold the harness in place. All right, there's that one. And if you look right below it, there's another one down there. There's a second one. This is for the rear position sensor wiring. All right, and there's even one further down here that it's really almost can't see. I can put my hand on it. Okay, it's right down there. And the point being is, hey, let's make sure we get those back in their original spot too. Okay, we don't want this kind of stuff flapping around in the breeze or getting caught on anything when someone's driving it off-road. Okay, because you're going to do damage real fast. So just make sure that you get everything back in its original location. Okay? One final point here before I turn it back to Mike is our motor. Now, if we have a fault with this motor, we're going to see a C0538. C0538 is a DTC that's going to lead our diagnosis to that motor. Now, Mike, one other thing here. I like to call the motor a plug and play.
Oh, yeah.
If you got to replace this motor, we can just bolt the motor on, plug it into the control module, secure our harness and our wiring. We're good to go. We can ship that vehicle. We don't have to perform the alignment.
But that's the only one.
That's the only component. Anything else, rear position sensor, tie rods, rack, control module, ball joints, wheel bearings, steering wheel position sensor, any of those components, you have to do this alignment procedure we're about to call out for you here in just a few moments.
All right. Well, we talked a little bit about this motor. Hey, we better talk a little bit more about how it actually operates. How does this thing actually function electrically? Well, the first thing we want to show you here is we got a three-phase DC motor. Well, to control this thing, we got to know exactly where it is in its rotation. So, inside the motor assembly, we got 3 Hall effect switches, Hall A, Hall B, and Hall C. You can see here, we're also going to supply a 12-volt reference in and a return, or low reference. So, with that said, again, all inside the motor. If there's any problem with those signals are not working correctly, It's a motor assembly. You can't go in there and just replace them. It's part of the assembly. Nothing you can do with it. You got to replace that motor assembly, like Andrew was just talking about. Okay, the wiring and clips and everything else got to get replaced. All right, so now we see how the system knows exactly where the motor is in this rotation. Now let's go ahead and take a look at the electrical schematic for this motor assembly. And there it is right there. Well, add 3 Hall effect sensors for the 3 phases. We've got phase A, we got phase B, and phase C. Now, we're going to use those Hall effect sensors to tell us where we're at right now. Once we know that, say we're on A. We want direction, rotation in one particular direction. Go from A, next up we'd power up B. From there we'd power up C, and then back to A. Gives you rotation in one direction. If you want a rotation in the other direction, well, it starts out at A, powers up C next. Back to B, over to A, there you go, rotation in the other direction. And that's what we need to do. Turn the wheels left, turn the wheels right. So that's how we actually move the motor. Here's our motor right in the center of this assembly here. You see the wiring going to it, 3 different phases. Also see we have a shorting relay here. This is kind of a little bit different. If you look at the contacts in this thing, it's going to work a little bit backwards from what we usually expect. All right? When we power up this relay, the module supplies power and a ground. At that point, the contacts will be in this open position like they are right now. If we remove that power or that ground, shut the module down, shut the key off, whatever, that's when the contacts are going to close. And if the contacts close, what happens here? Now, if you follow the schematic, you'll see that all 3 phases of this motor are going to be shorted together. Now, as the motor rotates, because of that return to center spring that we talked about earlier, it's going to generate electricity. Now it's going to be shared with the other phases of the motor. What that does is causes the motor to act as an electromagnetic brake. Okay? It slows down the return to center. The spring would be pretty abrupt and snap it back into place. This motor shorting relay combination, shorten the 3 phases of the motor together, it's just going to slow that down. It's still going to get back to center reasonably quick, but it's not going to be a snap. It's going to be a nice, gentle motion. Again, we are working with a 3-phase brushless DC motor here. All right, well, I'll tell you what, got another question for you. This is number 9 on your keypads. When that motor is serviced, you should A, replace the lubricant, B, perform an alignment, C, recalibrate the control module, or D, protect the gear set from contamination. All right, taking a look at those results. D is the correct answer. We want to protect that gear set from contamination.
Okay, hey, again, any questions for Mike or I, feel free to press that button. In the meantime here, we're starting to come to a close on module number 2. And to help us kind of pull it all together here, we have an exercise. Let's take a look at this exercise. It is on page 2-24 in your book. All right, we have the components and the corresponding function. We want you to connect the two. The steering wheel position sensor. Hey, that's an input to the controller. Next up, we have the rear wheel steering control module. That's what commands the rear actuator. And finally, the rear actuator, that's what positions the wheels.
All right, well, we've talked about all the different components that we have in this system. Once again, it is time to start pulling things together. Let's take a look at another video. This is going to show you all these components working together to create this rear wheel steering system.
We will explain system operation by looking at its sensor data. The steering wheel position sensor continuously monitors the position of the steering wheel and tells the control module the number of degrees from center the steering wheel has been turned in either direction. The mode select switch provides a driver selectable input to the control module of the desired steering mode. The vehicle speed sensor is a multi-purpose sensor that continuously monitors the vehicle speed and relays this information to the control module so it can, in conjunction with other inputs, determine the rear wheel steering phase and the amount the rear wheels will be turned. The yaw rate and lateral accelerometer sensor only records history data. It has no effect on the operation of the system. The rear wheel steering control module output consists of 3 voltage phases applied to the rear wheel steering gear motor. All 3 voltage phases are required to power the motor and operate the rear actuator. The last rear wheel steering input comes from the rear position sensor. This sensor monitors the position of the rear actuator and continuously tells the control module what position the rear wheels are in. This information, along with other inputs, is used to determine the rear wheel steering phase and the amount the rear wheels will be turned.
All right, none of these components are really all that complicated. It's not that big a deal. Start rolling everything together, though, it is a pretty sophisticated system.
Okay, hey, we're finally at the end of module number 2. Let's summarize what we covered in the second module while we're waiting to see if anyone has any questions. All right, taking a look. We talked about system components. We talked about system components and their operation. We talked about unique system features. And we talked about diagnostic information. Hey, we tried to give you DTCs and wherever possible and what ones you may expect per certain faults. Okay? All right, with that being said, we're ready to get into module number 3. We're going to talk all about alignment, this alignment procedure we've been alluding to the whole program here. Okay, it's really not all that complex. But if you would, turn to page 3-1. We're going to talk about alignment procedures and guidelines. We're also going to talk about special functions. Okay, what special functions are available to us via the Tech 2. Now, before we get into the alignment guidelines, we want to remind everybody that the motor can be replaced separately. You can unbolt it, you can bolt the new one on, and just plug it in, and it's good to go, man. You can ship that vehicle and get it rolling. That's the only component throughout the whole system. Everything else, you're going to have to follow through with this alignment procedure that Mike's going to lay out for us. Mike?
All right, again, now this is pretty simple, pretty straightforward type stuff. It's not a big deal. We're going to need to use the Tech 2. We've got 4 major steps that we want to talk about in this procedure. Now, the first is we've got to go in, check for any DTCs. If we've got them, we got to fix them and then clear them. That's an absolute must. The reason is we need to get into special functions in rear wheel steer. You can't do that if there's a DTC. It will not let you into special functions. So you got to fix it, you got to clear the DTCs out. Now, once you've done that, next thing is we're going to clear the learned alignment parameters out of the module. Again, using the Tech 2. Then we're going to perform the mechanical alignment, which means we've got to put it up on the rack, check the angles, make adjustments as needed. And then finally, we perform the learn alignment procedure. Well, let's jump right into this. Let's take a look at exactly what we got to do. Obviously, again, we're going to take care of any DTCs, get that fixed here. Once we do that, we're going to go in and clear the learned parameters. We've got to connect the Tech 2, follow special function instructions. Then Tech 2 is going to instruct you to turn the ignition off and perform the mechanical adjustments as necessary. You may not have to touch anything, but you got to check the angles, make sure that it's right. If everything's in specs, we're good to go. Go ahead and press continue. Then they have you start up the engine. Check, make sure that the rear wheels are centered up. You may want to lift them up to be sure of that. Also, use your rack, your alignment rack, to check that. If everything's okay, press continue again. Now the Tech 2 is going to direct you to turn the steering wheel 90 degrees or a quarter turn to the left. Then center it back up and go 90 degrees past center to the right. The system learns the front and rear sensor positions at that point. And the Tech 2 is going to verify that for you. It's going to say right on the screen, learn alignment procedure has been successfully completed. So again, not too big a deal.
Okay, now that's if it works right.
Always works right, doesn't it?
Yeah, maybe for you. All right. In cases like mine where it doesn't work right, okay, it doesn't go as smooth as you hoped or you planned, a couple of different things are going to happen. Now, if you remember earlier on in the program, we showed you the 3 mode lights that'll illuminate. That's one thing that'll give you a heads up that maybe the learn alignment part of it didn't take. But in addition to that, probably what you're going to see first is the message on the Tech 2. All right? And here it tells us the learn alignment procedure was unsuccessful. And it tells us to select continue to retry. Okay? So you just press the continue soft key, and it's going to give you 2 more shots at this. Okay? 2 more shots on top of the initial time. Let's see here, 2 plus 1. That's 3. All right, that gives you 3 attempts to do this. If upon the 3rd and final attempt it still doesn't work, the Tech 2 is going to bump you out. All right, and what you have to do is you got to refer to SI at this point. You got to build the vehicle in SI, navigate your way through to rear wheel steering, get into diagnostics. All right, you're going to have to go into symptom-based diagnostics. All right, and it's actually called unable to perform learn alignment procedure. Okay.
Amazing, they kept the titles the same.
I know. The title on the Tech 2 is the same as SI.
Wow. Where'd they come up with an idea like that?
What a concept. So look up that. Among other things, it's going to have you check your rear position sensor. It's going to have you check your steering wheel position sensor, because it's going to want to make sure that those are straight ahead, those are in line. Because if they're not, maybe if they're installed incorrectly or you got a bent component somewhere that's causing those things not to line up straight, it's not going to allow the learn alignment to take, to lock in. So keep those thoughts in mind about that. Okay. Okay. Up next, I guess special
question,
functions.
don't
Do we?
We got another question for you.
Oh,
Number
there it is.
10. Before clearing the controller learned parameters, it's going to be important to A, turn the ignition off. B, run the engine for 5 minutes. C, diagnose and repair any DTCs. Or D, learn sensor positions. All right, there's our results, and C definitely is the correct answer here. Okay, C was diagnose and repair any DTCs, because you can't get into special functions. You can't get into special functions if you have a DTC store. We've got to get into special functions to do this alignment procedure. Just that simple. All right, well, let's move on. Hey, got to remember, once we go through that procedure, you want to take it out for a test drive. Make sure it works in all 3 modes. Okay, make sure it's working in all 3 modes. Now, we want to tell our customers they don't want to drive it in the tow mode if they don't have a trailer back there. Handling characteristics change a little bit. Obviously, you got to do that to make sure it is working in all 3 modes. All right, let's continue on here and talk a little bit about what we can do with special functions in the Tech 2. We looked at one possibility there, right? What else can we do here? Well, we've got a video, and it covers different portions of our special functions. Let's take a look.
As you would expect, the rear wheel steering system offers a bidirectional interface for scan tools, such as the Tech 2. Functional output tests allow you to verify proper operation. The functional output tests are listed by selecting them from the chassis menu. The functional output tests allow you to activate system functions. As you scroll through the choices, you'll see specific system actions as well as choices which operate the system indicator lamps. Let's review the capabilities. Using command rear steer, left or right actuates the system to the commanded position. When on is selected, the rear wheels are steered to the commanded position. When off is selected, the wheels return to the normal straight ahead position. In each case, you can note the changing data parameters, most notably the rear position sensor. Selecting one of the 3 mode commands allows you to place the system into that mode. The selected parameter should be displayed until off is selected. There are 4 separate mode lamp tests possible to verify operation. You can operate each of them individually as well as turn them all on at once.
All right, so in special functions, we can go in and control the lamps, we can control the motor, and we can use it to be the switch in the system. So if the mode switch doesn't seem to be working for you, here's a great opportunity to diagnose that system. Use the Tech 2. Try it there. If it works with the Tech 2, it switches modes for you, good chance we got a wiring problem or a bad switch. A few things to check out there. All right, I think we're about ready to wrap this thing up. What do you think?
I think so too. Maybe we should ask for some final questions.
Absolutely. Any thoughts, any questions on this thing, please give us a call. We'll try and get that stuff answered for you here. Meantime, I think we're ready to go ahead and start summarizing what we covered.
Okay, let's take a look at the Module 3 summary. Okay, what did we cover here? It's pretty straightforward. We talked about the alignment procedure. We talked about special functions. What did we learn overall today? Session summary. That's next. All right, we talked about, well, we identified rear wheel steering system and its benefits. We identified rear wheel steering system components and how they operate. We described the unique features of the system. And we identify diagnostic procedures and where you should go and what you can expect if you have any faults with the system.